Hello again, everyone. This is Mr. V. Hill, and today I'm going to be talking to you about systems of equations and word problems. Now, one of the main things to understand with these word problems is they all kind of follow the same format using very similar equations, or different versions really of the same darn equation. And it's an equation that you all know very well, which is, of course, rate times time equals distance. Now, more important than just this equation, though, is the way the units work in this equation. So, for instance, rate times time equals distance. In this case, we might look at a rate, or the units for rate, as, say, I don't know, miles per hour, right? Which means a certain number of miles divided by a certain number of hours. Normally we want the number of hours to be 1, so we get a unit rate, but it's not really necessary. But we have the rate in miles per hour, and we're going to multiply that by time, hopefully in the same units as what's on bottom here. So we multiply that by hours. And what happens, of course, is we're going to get a distance out in miles. The reason being, of course, well, we're multiplying these two fractions together, really, if you want to think about hours as hours over 1. Hours cancel out, and what we're left with is just miles. Okay. So every single word problem that we're going to be dealing with involves some version of this equation. So let's just do an example here. And this will be a mixture problem. So suppose, I don't know, we're at Whole Foods or something and we're making some trail mix. And the trail mix is going to involve raisins and nuts. So suppose that raisins are going to sell for, say, $3.50 per kilogram. That's a rate. Per means divided by, so we really have a number of dollars divided by a certain number of kilograms. And suppose nuts sell for perhaps $4.75 per kilogram. And what we want to do is we want to make a mixture of raisins and nuts. And so what we want to know is how many kilograms of each should be mixed together to make, let's say, 20 kilograms of a mix, and that mix we want to be worth, let's say, $4 per kilogram. So we want to know how many kilograms of raisins we're going to need and how many kilograms of nuts we're going to need to mix together. So we get 20 kilograms, and that mixture is going to be worth $4 per kilogram. All right. So the basic equation we're going to be using here is similar to this rate times time equals distance one. It's a unit cost times the total amount is going to equal to the total cost. Let's think about the units we have here. The unit cost for each of these things is in dollars per kilogram. And if we multiply that by the amount of each, which is of course going to be in kilograms, how many kilograms of each do we want? That's going to equal the total cost. Kilograms cancel out. Total cost is going to be in dollars. Okay. So before we even get all this, everything set up, we should also just assign some variables. We want to know how many kilograms of raisins we're going to need and how many kilograms of nuts we're going to need. So those are the two things, well, that's what we're looking for, and it's also what we're going to be assigning variables to. So let's do that. So first off, and you could use any letters you want, but X and Y are always good for me. So let X equal the number of kilograms of raisins that we're going to be using. And we'll let Y equal the number of kilograms, oops, not or, of nuts. And again, we're going to be using this equation right here. Unit cost times amount is equal to total cost. I'm going to organize what we know and what we're looking for into a table here. Just to keep everything nice and organized and accessible. So first, I'm going to deal with the raisins. And the unit cost for the raisins is, of course, back here at $3.50 per kilogram. So I'm going to write this as 3.50. And I'm going to write my units this way, dollars per kilogram. Or $3.50 per 1 kilogram. You could also write it that way. And we now have X kilograms of that. And therefore, if we multiply $3.50 per kilogram times kilograms, we're going to get the total cost. 3.5, don't need to write the 0, times X, and that is in dollars. Next, let's deal with the nuts. Nuts are selling for $4.75 per kilogram. And of course, we've got Y kilograms of those. Multiply them together, and we end up with the total cost of 4.75 Y dollars. Because of course, kilograms on bottom will cancel with those kilograms, leaving just dollars. But then we've also got to deal with the mixture. We're given some information about that too. So the mix, the unit cost of the mix here is $4 per kilogram. And we also know that we want to make 20 kilograms of that. And so unit cost times amount is going to equal the total cost, which is going to be 4 times 20, which is $80. And well, there we go. We're looking for X and Y. But this is kind of nice because these two columns here really are going to provide us with a system of equations. Because in this column right here, we know we want to have 20 kilograms total. Well, that total 20 kilograms is going to come from these X kilograms of raisins and these Y kilograms of nuts. So our first equation for our system is going to be X plus Y is equal to 20. But then also, the total cost of the mixture, well, that has to come from the total cost of the raisins and the total cost of the nuts. So we also have 3.5x, that's the cost of the nuts, excuse me, of the raisins, plus 4.75y, that's the cost of the nuts. That should equal a total of $80. And therefore we now have a system of equations which we can solve to figure out what X and Y are, because that's exactly what we were looking for. The number of kilograms of raisins and the number of kilograms of nuts. And I'll just leave that as an exercise.